Alright, 6.6, use proportionality theorems. I can use proportions with a triangle or parallel lines. Here's your first example. I'm basically going to show you how it works. We've done this stuff before. Example 1, find the length of a segment in a diagram. QS is parallel to UT, and we see that by your arrows on there that those are parallel. RS is 4, ST is 6, QU is 9. What is the length of RQ? Here's RQ. I don't know what it is, so I'm going to call it X. So, if our lines are parallel, these parts are going to be proportional to one another. If those lines are parallel, those sections, those segments are going to be proportional. So I say X compares to 4, 9 compares to 6, then we can cross multiply. Yes. 6 times X is 6X, 9 times 4 is 36. We divide, X equals 6. So here it says, determine whether AB is parallel to CD. I want to know, are these two segments parallel? If they're parallel, this part is proportional to that part. I want to know, are each of those proportional? So if I have 90 to 72, I simplify it, see what we get. I have 50 to 40. I simplify it, I see what I get. If they're the same, yes, those lines are parallel. Cross off your zeros, that one's easy. We get 5/4. Divide them both by 9 to start. Half of that. 5/4 equal to 5/4. Yeah. These two sections are proportional. So are the lines parallel? We say yes, AB is parallel to CD. That's it. That's like the whole lesson in a nutshell. How about here? Find the length of YZ. Here's YZ, call it X. If these lines are parallel, this is proportional to that, and 36 is proportional to 44. So X to 35 equals 36 to 44. We cross multiply. We divide. 28.63. Like that. Okay. Funky decimal, right? So here's what I would tell you to do. Does this make sense? If I put 28.63 here, it's smaller than 35. 36 is smaller than 44, so kind of maybe. Take this and divide it. What's 35 divided by 28.63? 1.222. Okay. And then we have 44 to 36. Divide those two. What do you get? 1.22. So that tells me I did it right. Yeah, this is a funky number. We don't like that too much. But this 44 to 36 simplifies to 1.22. 35 to 28.63 simplifies to 1.22. They're both proportional to each other. We got it. Number 2, we just did that one. That's like a typo on the worksheet. We're not going to do that second one again. Really, with this one, what happens, if you have 3 parallel lines that intersect 2 transversals, they divide the transversals proportionally. So these parts are proportional, and those parts are also proportional. How about here? Find the length of AB. Here's AB. Call it X. I have my parallel lines in here, so I'm going to say what is proportional to what? X to 18, 16 to 15. Draw on your arrows so you don't get confused. Cross multiply. X equals 19.2. Thanks. So I put my 19.2 up here, and I'm like, well, does this make sense? 16 is just a little bigger than 15. 19.2 is just a little bigger than 18. So when you divide them, they should divide to be the same number. This one, there's really not a lot of math in this one. Here's here's what I want you to do. If it says find AB, to find this side length right here, you can probably take a guess at what it's going to be. If this is 4 to 4 square root of 2, this is going to be 4 to 4 square root of 2, because they still need to be proportional. If these are the same, those have to be the same.